This video is going to go over several examples for lesson 7.7, which is on applications of rational equations. Question number 12 tells us that the focal length f of a lens is given by the equation 1 over f equals 1 over x sub 0 plus 1 over x sub I, where x sub 0 is the distance from the object to the lens and x sub I is the distance from the lens to the image of the object. If the focal length of a lens is 12 centimeters and an object is 3 times as far from the lens as its image, then how far is the object from the lens? So the tricky part with this question is that they don't give us any kind of diagram to help us visualize what's going on in this situation. So what I have sketched here is what happens when you have a lens focal length and that kind of diagram that's describing the situation. So we have our object, and then the object distance, and then the image distance is here. So this is just, again, a quick sketch of what this focal length is talking about in terms of an actual diagram. So now that we've seen the setup, let's go through and actually solve this rational equation that needs to be not necessarily set up because they give us the equation, but we need to plug in some information. So keep in mind the equation they told us was 1 over f equals, and then it's 1 over x sub 0 plus 1 over x sub I. So in this problem, it tells us that the focal length is 12 centimeters. And remember, f is representing the focal length. So this is going to turn into 1 over 12 equal to, and then the x sub O is going to be 3x because we're letting x be the image length. And so it tells us that the object is 3 times as far from the lens as its image. So we're going to have 1 over 3x plus 1 over x. So again, x is our image distance, and then the object is 3 times as far as that image distance. So now that we have this equation set up, this goes back to the previous lesson where we were solving equations that look like this. We need to find a least common denominator between 12, 3x, and x, and we're going to multiply the entire equation by that least common denominator. In this case, the least common denominator is 12x. So we're going to multiply the entire equation by 12x, and what's going to happen is all of our denominators are going to cancel out. So when we do this, again, we have 1 over 12 that we're going to multiply by 12x equal to 1 over 3x that we're going to multiply by, again, 12x, which again, you can think of this as being over 1, if that helps you to keep things lined up, plus the 1 over x, again, multiplied by the 12x over 1. So again, we multiply every single part of the equation by that common denominator. And then some of this is going to cancel out. So the 12 and the 12x, the 12's cancel out, and we're left with just x equal to, and then this 3x and 12x, the x's cancel out, and between the 12 and the 3, you're left with a 4 after you do some cross-canceling there. So we got 4 plus, and then over on this side, we're going to actually be able to cross-cancel the x's, and so we're left with 12. And so we get x equals 4 plus 12. 4 plus 12 is 16. So 16 centimeters is the image length. So to figure out how far the object is from the lens, remember it was 3 times that distance. So 3x is going to be 16 times 3, which is 48 centimeters. And that would be the final answer for that question. Our next example is about planes and wind speeds. So this question is number 14 out of the book, and it says a plane can fly 500 miles against the wind in the same amount of time that it can fly 725 miles with the wind. If the wind speed is 45 miles per hour, find the speed of the plane in still air. So we're going to let r equal the speed of the plane in still air. So the speed against the wind is r minus 45, and speed with the wind would then be r plus 45. So again, we're going to let r be the speed of the plane in still air, which is what we're trying to find. But we know that the speed against the wind is going to be r minus 45, and the speed with the wind is going to be r plus 45. This question is going to involve our formula for distance, which is distance equals rate multiplied by times. And so with this, again, it tells us in the question that it flies the same amount with the wind and against the wind. So using that information to set up the start of this equation, the time against equals the time with the wind. Now, time, again, can be wrote, again, our formula, D equals R times T. We can solve this for T by dividing by R. So this formula also tells us that the distance divided by rate equals time. And that's what we're going to end up using, because we don't know the time other than the fact that it's the same. But we do know also that there's this distance, and we know the rate in terms of variables, which is going to allow us to solve for R. So this we can replace by saying, okay, we have the distance over the rate, again, for against the wind. We're going to set that equal to the distance over the rate for with the wind. And now we're going to plug in what we know. So it flies 500 miles against the wind. So we're going to have 500 over, and the rate against the wind, remember, was going to be R minus 45. That's what we use to represent that. Equal to, with the wind, we flew 725 miles. I almost said drove, but we're flying a plane. So 725 miles that we flew. And then the rate we represented with R plus 45, since you have that wind helping push you along. And then now that we have this set up, we just do our cross products and we're going to solve for R. So doing our cross products, we're going to do 500 times this whole quantity of R plus 45. Then we're going to do the same thing with the other cross product. So we're going to have 500 multiplied by R plus 45 equal to, and then 725 multiplied by R minus 45. Both sides require using the distribution property, so we're going to do that on, again, both sides of our equation here. 500 times R is 500R. 500 times the 45 is 22,500. 725 times R is 725R. Minus, and then 725 times that 45 is 32,000, and then 625. So now we solve this. So I'm going to start off by subtracting 500R. Again, you have a lot of options to solving these equations when variables are on both sides. There's actually 4 different ways you could start this. I try to find the way that's going to leave me with a positive coefficient in front of the variable, and this is the option to do so. So we're going to have 22,500 left on the left-hand side. 725 minus the 500R is going to give us 225R. And then we still have this 32,625. We're going to add the 32,625 to both sides, and when we do that, we're going to have 55,125 equal to 225R. And then our last step is to divide both sides by 225. And we're going to find that our rate in still air is 245 miles per hour. And there's that problem.